This lesson is on section 9.5 titled Direct Variation. What a direct variation is that when the ratio of two variable quantities is constant. So it's a constant relationship. That's going to be a pattern throughout this lesson. So the first example says the amount of money Robin has raised for a bike-a-thon is shown in the graph. Determine the amount that Robin raises for each mile she rides. Okay, we know it's a constant relationship, so every point should give us, a constant value here. So what we're going to do is we're going to take the amount raised. So we're going to take my my x or y values here. We're going to take the amount raised, and we're going to divide that by the distance. So we're going to take your y over x. And that's kind of the same what we've done in our other lessons where we did rise over run. That same idea with slope. So amount raised over my distance. So you can think of rise over run, the same thing. My y's over my x's. So we can pick any point. We can look at all these points here. So amount raised. So it looks like this point here. So we can look there. It's going to be 15, and then over 2. So raise is 15 over 2, and that's going to be about 7.5. We should always double check using our other values. Because it's constant, we should get 7.5 every time, but let's just double check. So we have this point here. So we have this value. So this is the point, 430, or we can say 34. So we can do 30 over 4. Well, 30 divided by 4 is also 7.5. And let's check the final point. So it looks like it's 45 over 6. Again, when you do the dividing, you're going to get 7.5. So it says determine the amount of that Robin raises for each mile. So she raises $7.50 per mile. So again, all we had to do was look at each of the given points. We did our rise over run, or we did the amount raised over our distance in this example. So y divided by x to get our constant value. And that's how we figure out the amount of money she raised. Let's look at the next example. A grocery store sells 6 oranges for $2. How much would it cost to buy 10 oranges? So we've done examples like this where we set up two equal proportions, and I think I'm going to use the exact same way to do this. Because it's a direct variation, we can set them up as equal proportions or equal fractions. So we can say 6 oranges for $2. We want to know how much would it cost. We want to know how much would it cost for 10 oranges. Notice I put both the oranges in the numerator. And we can do that fish method, well, because there's no common relationship between that 6 and the 10. So we can't simplify anything here, or we can't say how do we go from 6 to 10. There's no common or a whole number. So we can say 10 times 2 divided by 6 is going to be x. Remember that fish method? So 10 times 2 divided by 6. So 10 times 2 is 20. So then 20 divided by 6 is going to be about $3.33. Easy as that. Just direct variation is also the same way as setting up two equal proportions, which we have done in the past. Finally, it says determine whether each linear function is a direct variation. So we want to see, is there a common, think of a common pattern. Does that pattern say constant? So if so, say the constant of variation. Okay. So in this one, we're going to do, again, our y over x, our gallons per mile. So let's look at each one. So we have 1 over 25. We can't simplify that anymore. So then we have 2 over 50. Oh, that equals 1 over 25. So far, so good. Kind of circle that. So then my next one here is going to be 3 over 75. We can reduce that down, divide them each by 3 to get 1 over 25. Oops, so far so good. And we got one more to do. 4 over 100. Divide those both by 4 to get 1 over 25. So we can say, yes, it is a direct variation, and that constant of variation is 1 over 25. So you could say yes, and then comma 1 over 25. That's my final answer there. Okay, so let's do one more example. So in this case, we have hours and earnings. So kind of earnings per hour here. So we have earnings per hour. Okay, let's go through each one. So let's start with this one here. 36 earnings per hour. So 36 divided by 2 is 18. So far we have 18. So we should get 18 every time. Okay, so then I'm going to do 52 divided by 4. And that's going to get 13. So looks like these are not a direct variation. I'm going to just try one more. It's always good to go back and check just to make sure in case I did the math wrong on any of them. Let's do 68 divided by 6 just for kicks. So when you do 68 divided by 6, we're going to get like 11.3. So right away that tells me there's no common pattern. There's not a constant, variation. So it's not a direct variation. So we can't, so we can just say no right there. Again, we're just looking kind of at the patterns of the graph. Please remember in this whole lesson, make sure you're doing your y's divided by x's, your rises divided by your runs. And that brings me to the end of this lesson on direct variation. Thanks for watching.